Hello and welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to discuss how to answer a question to do with electricity. For instance, here you are told that state the formula linking voltage, current, and resistance. We know in order to answer this, we're going to say that voltage is equals to current times resistance. And some of the things that you need to remember in this kind of a scenario is that in this case, when you are doing a question like this, you need to check whether the value that you are given, are they in the SI unit? The units, are they in SI unit? For instance here, voltage must be in volts, current must be in amperes, and resistance must be in ohms. So that when you are given a question and it is given in kilo amperes or in milliamperes or in kilo ohms, you know exactly what you are going to do in that kind of a situation. Calculate the current in the resistor here, because the voltage in that case is actually, the voltage is 5.8 volts and the resistance in this circuit is 13 kilo ohms. So that's why I'm saying the units, you must be very careful with that, because here is kilo and we know in physics that kilo is the same as 1,000, a mega is the same as 1 million, because now in this case if you are given kilo ohms, it means 1,000 ohms. If you are given mega ohms, it means 1 times power 6 ohms. If you are given giga ohms, it means 10 raised to power 9 ohms. So these are some of the things that you need to be very, very careful with. Now, calculate the current. From this formula, we have said that voltage is equivalent to current times resistance, meaning that we can be able to rearrange this equation so that we are able to work out the current. And in that case, what we're going to say, our current is equal to voltage over resistance. And in this case, we are going now to take the voltage, which is 5.8 volts, divide by the resistance, and the resistance here is actually 13,000 ohms. This is volts. So if we work out this, if we use our calculator, we are going to get, this is going to be 5.8 divided by 13,000. If I just put that in the calculator, I'm finding my answer is that, so we can be able to write it in decimals. This is going to be 0.00. We can even write it in standard form, which is going to be 4.46 times 10 raised to negative 4 amperes, which is approximately 0.000446 amperes. We can be able to get it in that form. And if you're new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload new tutorials, you'll be notified. All through, we'll be working questions that are giving you problems. So there's every reason as to why you should subscribe, so that when I'm going to upload new tutorials, you'll be notified so that you cannot be able to miss any of my videos. So take this moment so that you can be able to subscribe, and also leave a comment down below if there is any question that you really feel, or if there is any section you've feel that you've learned something new. It will be very, very important for us. So we need to go to the next bit of this particular question. All right, so we need to move to the next part of this question, because we are told that complete the circuit by adding a suitable meter to measure the current in the resistor. Remember, a suitable meter in this case, we are measuring current. To measure current, so current is measured using an ammeter. But if we were told about voltage, we were supposed to use a voltmeter. So in this case, and we are measuring the current in which section? In this section of 13 ohm, 13 kilo ohm resistor. So in that case, we are going to add our ammeter in this part here, and we shall say this is our ammeter for that case, because this is in the branch where the current is going to flow through this 13 kilo ohm resistor. But if you are supposed to measure the current throughout the circuit, current that is flowing throughout the circuit, or the total current flowing the circuit, when this one is closed, we are going to put an ammeter at this given point. So something else that I need to mention at this point is that if you are told to add a voltmeter to measure a voltage of a component, that one is supposed to be added in such a way that it's actually parallel to the component. So if it's a voltmeter we were supposed to add, in that case we were supposed to add it at that point. So the correct answer for our question in this regard is actually this one. Don't be confused, because I've already mentioned as to the reason as to why I've added all. This one will measure the current in the entire system, in the entire circuit. This one will measure the current going through the 13 kilo ohm resistor, and this one here is going to measure the voltage drop across the potential difference of the 13 kilo ohm resistor. So we need also to look at the switch. This is the switch we are talking about of the circuit is closed. Explain what happens to the current in the 13 kilo ohm resistor. What happens to the current in the 13 kilo ohm resistor? Now, before we go to work out this question, there's some few things I need you to appreciate here, and that is when this circuit is actually closed. When this circuit is closed, we are going to have this resistor working and this other resistor also there. So the total effective resistance is going to be calculated by 1 over resistance R total over 1 over resistance. Let me call this is our R1, and this is our R2. So which means that we can be able to say that we are going to add 1 over R2, this one here. So 1 over R total is going to be 1 over 13,000 plus 1 over 200 ohms, which will mean that if we add this, what is it going to give us? R total. Let me just put it in the calculator so that we can be able to see what we are going to get. This is 1 over 13,000 plus it's taking long. Let me just move it quickly. Plus 1 over 200. It's giving me actually is giving me 33 over 600, 6,500, as you can see here. So meaning the total resistance here is going to be 33 over 6,500. So meaning that if we want to find R total, we need to find the reciprocal of the two. This is R total equals to 6,500 over 33. So if we work it out, we are going to get that value. I find the reciprocal of this is giving me actually 6,500 over 33. In decimal, that is 197. 197 ohms. 197 ohms. So something that you need to realize at this given point is that when this switch is closed, the total resistance in the system is 197. But if this circuit is actually open, the effective resistance, because this will not be connected, it will not be connected to be open. So meaning the total resistance will be 13,000 ohms. So which means when the switch is closed, resistance drops. resistance of the circuit drops. So more current is going to flow, more current is going to flow through the circuit. So the current in the battery is going to be higher because the resistance in the circuit is less. So we're going to say current through the battery increases. The current increases, but here current remains the same. Current remains the same because voltage remains the same. Remember here, the voltage across this resistor is 5.8. The voltage across this resistor is also 5.8. So we mean that current in this part is going to remain the same because voltage and the resistance remains the same. So here we are going to say current through the battery increases because voltage remains the same, but resistance decreases. When resistance decreases, it means more current is going to flow through that battery. But since in this section here, I've actually repeated that since voltage remains the same and the resistance is the same, then it implies that the current from the resistor or through the resistor is going to remain the same. If you have learned something new from this particular video, consider subscribing so that when Prof Learn is going to upload another tutorial, see you in the next video.